Good morning, ladies and gentlemen. Today we're going to talk about chemical bonding, the basics of chemical bonding. After today, you should be able to explain how ionic and covalent bonding occurs, be able to write Lewis dot diagrams for the representative elements, and determine the number of valence electrons for a particular atom. There are two types of bonding that occurs: ionic bonding, which involves a transfer of electrons. One element loses electrons and the other gains electrons, actually give their electrons away or accept them. Covalent bonding involves a sharing of electrons. Atoms will share in order to reach a stable electron configuration. The octet rule states that atoms will gain or lose enough electrons to become isoelectronic, or the same as a noble gas. Electron dot structures, which we have done first semester, so these should look familiar, are a way to show the number of valence electrons in an atom. Valence electrons must be labeled in this order: 1, 2, 3, 4, so one on each side. Then we go back and we pair them: 5, 6, 7, 8. The number of valence electrons can be determined by the group that the elements are in. These come from the S and P blocks only. So notice we have group 1, group 2, and we skip the transition metals and go to 13 through 18. So I want to show you on a periodic table, we're just talking about group 1, group 2, skip these in the middle. We talk about 13, 14, 15, 16, 17, and 18. Okay, those are the groups we're talking about. So group number 1 has one valence electron. When we draw that, it looks like whatever the symbol is. So I'm just going to use the first one in the first group, lithium, and it's going to have one dot up here on the top. Okay. Our next group, group number 2, has two valence electrons. So it is going to look like whatever the element symbol is, and then two valence electrons, two dots. Group 13, so again, we skip the transition metals, go to 13. Group 3, has three valence electrons. So that's like boron, aluminum. So they have three dots. Group 14 has four valence electrons or four dots. So that's like carbon, silicone. If they are in group 15, they're going to have five valence electrons. So we are going to draw them, whatever symbol they are, and then we do one on each side, and we pair up the last one. In group 16, they're going to have six valence electrons, which means it's the symbol, and then we draw one on each side, and we pair up two of them. 17, that's like that whole last group. So fluorine, chlorine, bromine, iodine. I'm going to draw iodine. And it gets seven valence electrons. Okay. And lastly, that last group of helium, well, not helium, neon, argon, krypton, xenon, and radon get eight valence electrons. So let's do argon. And they have two on each side. Okay, valence electrons, what they do is determine the chemical reactivity. Elements in the same group behave the same way. So if they're all in that first group, they are all gonna react with water. If they're all in the very last group, they're not gonna react at all. So what we're gonna do now is the charges that we memorized last unit, we're gonna come up with why they exist. So in group 1, we have something that looks like this. So we have lithium, and it has one valence electron. It either wants to go to 0 or 8 in order to be happy. If it has one, it is definitely easier to go to 0. So what lithium will do is actually get rid of its one electron. So it is going to lose one electron. And therefore, if it loses one negative electron, its charge is going to be +1. Okay. In our second column, we have something like calcium that has two valence electrons, and it is either going to go to 0 or 8 according to our octet rule. From 2, it is easier to get to 0, so it is going to lose 2 electrons. If it loses 2 negative electrons, its charge is going to be +2. In our so skipping the middle, in our group 13, we're going to have something like aluminum with 3 valence electrons. Again, it either wants to go to 0 or 8. 3 is easier to get to 0, so it is going to lose those 3 electrons. When it loses 3 electrons, its charge will then be +3. In group 14, we have things like carbon. Carbon has 4 valence electrons. When it tries to go to 0 or 8, which one's easier? Well, neither is easier than the other. So it can either gain or lose 4 electrons. That means it can have a +4 charge or a -4 charge. Okay. In group 15, we have phosphorus. Phosphorus has 5 valence electrons. It is easier for phosphorus to go to 8. So it's going to gain those 3 electrons to fill out its shell. Then its charge will be -3. In group 16, we have sulfur. It has 6 valence electrons. It is easier for it to go to 8 by gaining 2 electrons. If it gains 2 negative electrons, its charge is going to be -2. In group 17, we have chlorine, who has 7 valence electrons. It is easier for it to go to 8. Therefore, it is going to gain 1 electron for a charge of -1. Our very last row has 8 electrons around it. Since it already fills out the last, so it's obviously already 8, so that is called stable. So therefore its charge will be 0 or neutral. So when I find magnesium, I'm going to write the electron configuration for each of these ions. I'm going to look at the periodic table and figure out how many electrons each of these has to start. So on my periodic table, here's magnesium. It has 12 electrons. So I'm going to start with my 12 electrons with my regular magnesium. Then it says its charge is +2. In order for its charge to be +2, it has to lose 2 electrons. So 12 minus 2 is 10. When I look on my periodic table and find 10 electrons, that is neon over here. So my new element with the magnesium +2, the new element, its charge is equal to neon. So again, we took those 12 electrons, we subtracted 2 electrons, and we got 10, which is equal to neon. For phosphorus, phosphorus has 15 electrons. We are going to add 3 electrons because we do the opposite. 15 plus 3 is 18 electrons. If you look on the periodic table, that is equal to argon. Finally, we have bromine, who has 35 electrons. We are going to add 1 electron. 35 and 1 is 36, which makes it equal to now krypton. In our last little section, we're going to talk about what an ionic bonding is. So an ionic bond forms from the attraction between positive and negative ions. An ionic compound is made of crystals. A crystalline pattern consists of a three-dimensional repeating pattern alternating between the positive and negative ions. A formula unit is the lowest number of ratio of ions. Those are found through the subscripts. The ionic compounds have high melting points. They conduct electricity when melted or dissolved. And a very common example is sodium chloride. You'll notice one of these is from the left and one of these is from the right, just like in our binary naming. I hope you all have a wonderful day, and you're going to complete the worksheet. Let me know if you have any questions or problems.